Hi everybody, thank you for joining us again. I hope you enjoyed last week's video. I said it was going to be a good one, and I'll tell you what, it's really nice coming into the workshop this morning and seeing the Ranalah there with all of its parts in there, moves so nice and free. So many of you left some really positive comments. Thank you very, very much. Lots of helpful information, links to watch other videos. It's really, really just great to have the sort of support from you guys. So thank you very much. But anyway, we've got a lot to get through today. It's Bank Holiday Monday. I'm not at the repair shop, I'm in the workshop. We've got a lot to get done. First things first, let's go back in time when I just received delivery of the next Ranalah component. So I've just picked this up, but it's going straight off somewhere else. So I've run back to the workshop quickly because I just wanted to come and show you very quickly before it goes off to the next place, because this is exciting. Right, this is the original top wheel. That wheel is from my original Ranalah that I've got in the workshop. That's why it's been sitting like this for so long. This top wheel has been off, getting drawn, scanned, measured, traced. All sorts of things have been happening to this poor wheel to get to the point where I've now got in front of me the very first new, complete, exact replica of the original wheels. I've got a brand new one. Done. Well, it's not done, but I've got a brand new one here. Look at that. On the front face, it's got this threaded hole, which is a Whitworth thread. I think that is to do with holding a sort of dog to hold it in the lathe. This would have been in a big lathe, and they would have done a sort of like a pass across like that to sort of face off the surface, and there's a small little lip there. When they got to the center, they would have just sort of cranked in the lathe just a little bit and made a little scribe mark. I don't know if you can see it there. Just to show them where the center of that hole is to be. Things like that make sense on a manual lathe. As you're sort of facing across, you're measuring halfway, and then as you get to halfway, you can sort of nip it in and just make it scribe a little line. I do it sometimes on the lathe when I'm sort of working on the size of something, when I'm parting it off, when I know how long it is, sort of do a little sort of mark just so I can tell how long it needs to be. It leaves a little scribed line. So I can see exactly why they did that originally. Completely unnecessary these days because this has been cut on a CNC machine, so just a computer program would cut it all out. But I wanted to keep that little detail in there. It probably seems silly to some people, so I've lost the perfect smooth machine surface and now I've got a sort of scored line around halfway through. But it's those little things that I really like that I think is important to try and keep. And it's doing the same job. It's showing the middle, it's showing the center, and I've got the same Whitworth thread like on the front face, on both sides actually. So it's all, every little detail is exactly the same. I'm so pleased with this part. They are identical. We've got the same little lip. Then the bearings can sit in there. I've also got brand new bearings. Brand new bearings are going to fit nice and snug in there. There's no way I'm not pushing that in there now because it's quite a snug fit. But they are the same. They'll all cross over. That, sits on there. It's so cool to see new and old sitting next to each other. It's lovely. This is a really nice feeling. Just sitting in the workshop here, I've been sitting here for ages admiring it. A big thank you to the guys that have done all the CNC, all the drawings, the planning, the engineering and the cutting to get me to this point. Put the link below. If you need anything doing, any machining doing, they are your guys. They're brilliant. Done an absolutely fantastic job. I could not be happier. We have got a bit of a debate with colour here because fair enough, the main cast iron part is going to be grey. I do not know whether I should paint that inside face of the wheel, whether I should paint this little spacer part. Few people have said that I should engrave Ranalah or something, or a serial number or something onto this part that sits on the front, because that sits quite proudly on in the center of the top wheel. So it's asking for something on there, but I don't know, they never did that originally. There's never anything engraved on any of the originals that I've got, but oh, that looks good. So that new top wheel is made from a solid piece of EN24, which is very hard steel, which is hard in itself, but it's also hardenable. So the next step, it's not finished. The machining of it, to get to this point, there's been drawings and plannings and machining, but we're not finished yet. This is now going off to a heat treatment company where it's going to go in essentially an oven that's under vacuum. So the whole thing is going to be heated up to a certain temperature, makes the steel much, much harder. Then it will be cooled, it'll be quenched and cooled down very quickly and frozen at that point. Then it will be heated up, I think, 2 more times, which is like tempering, which kind of relaxes it all down a little bit. And we're going to get it as hard as we can. This is on the Rockwell scale, which is a sort of scale of measuring hardness of steel. I have tested the original wheel, and it was something. It was like 41, I think it was. Not very hard. I'm hoping to get this new top wheel once it's been through hardened and tempered. 55 and above, I'd be happy. If I can get near 60, that would be amazing. It'd be very, very hard. So there's a few more steps to go, but we are getting very close to the new Ranalah top wheels being available. These are something that I can sell that'll work perfectly on original Ranalahs. So any coach builders, anybody out there with an original Ranalah that's got a top wheel, an original top wheel, take my word for it, because I've tested both of mine, 2 of mine, and they're both pathetically soft. Even though they are the original wheels, they were originally case hardened, which is a very fine kind of like coating almost on the outside, which over the years, 80 odd years of use, has worn off, been sanded off, polished off. They're pretty much gone. And you're just left with a fairly soft top wheel. So these new top wheels are going to be available. So anyone out there that wants one, we're getting very close. Full of enthusiasm, but now skip forward a week. It's gone to heat treatment. It's been to heat treatment. It's come back. And it was a failure. These guys came back and said the hardest we were able to get it was 32 or 34, something like that. I was just like, man. But I think they said there was such a mass of steel, the part was so thick and so big, it retained the heat. They couldn't cool it quick enough. So there's nothing against the heat treatment guys. They didn't do anything wrong. It's just that particular process of the vacuum heating and however they cool it did not work for this part. So we're back to the drawing board. I've got it back here. It's not ruined, thank goodness, because this has cost quite a lot of money to get to this point. Back to the drawing board. I've got the wheel here. It's bank holiday, so I can't do anything today, but hopefully Tuesday or Wednesday, I'm heading down to Essex. We're going to go to Wilson Tools, who have got heat treating facilities. They've actually got everything we need to make these wheels. They've got heat treatment and then grinding, all sorts of stuff. So I'm hoping, fingers crossed, we're going to go down there Tuesday or Wednesday, take this wheel, they'll heat treat it and they cool it in a different way. They've got all sorts of fancy stuff there. So we're going to try, round 2, we're going to try and get this top wheel up into the 50s for the hardness scale so it can match, if not be a little bit harder than the original. The sun is shining. It's a beautiful day. We're on the way to Essex. We are going to see Mark at Wilson Tools, and I've got the top wheel with me, the top wheel for the Ranalah. We are going to drop it off to Mark. Hopefully he'll let us in to have a look around his workshop there. They're going to do the heat treatment again, slightly different process. We'll chat to him about. To do with the quenching, I think, is the main difference. Maybe they'll get it hotter, I'm not entirely sure. Hopefully they will be able to get the hardness up on the top wheel. Up in the 50s would be the absolute dream. So let's see what they can do. Next stop, Wilson Tools. I've got the wheel in my bag. We're here. Let's go inside, see if we can find Mark.
This one called 1250, so you've got 1250 movement that way, and you've got 30 tools in a carousel up there.
30, wow.
And these carry 24 tools. You can see the cover on the end now. See the tool change. We'll call out tool number, select tool, deburr. So the carousel is now turned around, pick the tool up.
Oh. Grabs it, chucks the next one in.
That's it. Done. So they're all preset. Not old school.
Oh, here we go. That's more like it. Yeah.
Yeah, you've got obviously movements. So you've still got the versatility of
that's great.
manually.
Yeah.
and you've got power on the knee, and obviously you've got the air drawbar as well. So similar to the tools for there.
Perfect.
So you've got your loaded, so your fly cutters and your drill chucks, they're all set up.
All set up on the so you can just push that in, so there's no fiddling around with a drawbar at the top. You're not.
Yeah, you just in and away you go.
That's so cool.
So
yeah, nice.
It's a nice usable machine for so many different types and shapes.
Yeah.
Now we come into the grinding area.
Oh, you do have grinding here as well?
Yeah.
Okay.
This one, I'm just setting the job up here. So this job here, basically the bore has got to be spot on to the outside diameter.
Right.
So what we do, we hone it and turn it roughly to, say, 4th thou in there, 0.1 of a millimetre. We hone it to size, so then that now is to the correct size, and then we make up a mandrel.
I see.
And that just knocks on. So now that runs between centres. So now we know that outside, when we grind it, will be
concentric to
the outside.
Which is exactly what my top wheel needs.
Yeah, that's it.
Exactly that.
Yeah. So and that one just fits in there between the centres. And obviously our driving dog at the back there, also located in. And then obviously I'm just setting up this to grind at the moment.
So the largest diameter you can do on this, my wheel's about 200 mil.
Yeah, so
that would fit, I think, wouldn't it?
Literally, if it'll go round, so you get 300 plus on there.
Yeah.
We've got over there. So this is a magnetic.
Is that magnetic? I was going to say. Yeah.
So you put your job on there. Basically, you move it around wherever you want it. This is a diamond for dressing the wheel, and then basically it's just a case of turn it on, and that's it, solid there.
And it's stuck.
Yep.
Yeah. And really stuck as well.
So basically, most jobs we do are magnetic, so obviously
that's amazing.
This stays on here.
So there's no jigging, fixturing, anything out, no T-slots, no bolting things down. You can just plug it on there.
And obviously this is ground, so this is
surface, this is flat.
This fence at the back here, so you can put parallels or jobs against it. So then when you're grinding, you know it's parallel. The job will be parallel with the.
So this lever must move align magnets or something.
That's it.
Inside.
Yeah, you've got levers inside. And then obviously that just frees it up.
That's amazing.
Little pins like the semi-CNC machine, that's what these are set up for. So these are all turned. Some of them are milled where we put the flat on for location.
I see, yeah.
And then that will be heat treated. I'll take you around in a minute.
And
then that will be ground.
Yeah, exactly.
That'll be ground between centres.
This is the Rockwell tester, yeah?
Yeah.
So is that what you would use?
Yeah, this is what I used on your original Ranalah wheel to check the hardness.
Check the hardness. So you basically crank this down.
So basically this moves down. You put your component underneath, depending if it's a flat or if it's a radial one. You could swap this top bit for a V.
Yeah.
Then you can put your component in. And then you just wind it up.
And that is diamond tipped, is it?
That's a diamond in there.
Yeah.
So basically then you wind that up onto there. Then you basically wind this round till it gets to the set point on the small dial. Then we just move that round to there.
Yeah.
And then basically it's on a big spring. So when you push that down, it basically...
So that's 40...
No, you have to release the spring to work out what it is. So that would be 52 Rockwell.
52 Rockwell.
Yeah.
Right. That's what I want. That's rubbing it in. That's exactly what I want the wheel to be.
Yeah. This is a superficial one, so this is not as aggressive as that, the spring on it. So
it won't leave that indent?
No, it's for softer, thinner materials.
So it won't go up to 50?
No. Yeah, it'll go up to 50, but it's on a different scale. And it's basically, it's just if it's a thin material, it won't put the pressure through it.
I see.
Yeah, so you don't get that.
So you don't actually even get, you don't get a printout or readout, or you just get
it's just this is
dial when you've got to look at that. It's very analog.
And we have setting blocks that are heat treated that we test it with once a week.
That's great to see. That's brilliant. So hopefully soon my wheel, top wheel, will be sitting in there.
Yeah.
And hopefully we'll be coming back round to here to 50 odd. Yeah. Perfect. The Edwards fly press. That's brilliant.
Very handy for straightening jobs, and also people bring press tools in for refurbishment, so we can, once we've ground it and repaired the tool, we can set it up and we can just run it basically, just to test it. So this is a restricted area purely because of the chemicals.
Oh, okay. Oh.
That's involved.
Hi there. Yeah, okay.
This is Jerry, our heat treatment.
Hi, Jerry.
So we've got 2 furnaces.
Well, this is like being back at the foundry.
Yes, it's very
serious, isn't it?
Process, yeah.
This is for heat treated, so this is where my top wheel will end up.
Yes, yes.
What, in there?
So one of these pots, this is out at the moment, but that sits inside there.
You're kidding. I thought it just went in an oven.
No. The burner is
molten there.
Yeah.
No.
The burner goes in there, so your flame comes round the pot that's sitting in here, and then that heats up.
Okay, so it's like indirect, so the part won't actually get in contact with the flame.
The part will sit inside.
The part goes in that tank.
Yeah, and that sits inside this.
What on earth is in there?
That's your salt, which melts. You heat it up to about 900 degrees, and then obviously that turns to like lava, and that's where you put your jobs in like that.
You're kidding.
So if you see that there, it's got the thrust.
This is cyanide in here.
Wow.
So that's at the moment is
833
So this is 830 degrees.
at the moment.
That is awesome.
Your wheel, the M24, will be done at 840.
So you put it, you'd literally, that wheel that's cost me so much money.
Yeah, you reverse.
You'll put it in there.
Yeah, that will soak in there, so then all the goodies will go into the material to give it the hardness that we require. You've got this
That is
side,
incredible.
which is like your preheat.
What?
So this is your main.
So you sort of warm up the part a couple hundred degrees or so.
Yeah,
get
that's it.
warm.
Before you put it in.
So there's no sort of thermal shock and stuff, I suppose. Yeah.
Yeah, so these are the small pins that we've got that are going in at the moment. Just see the colour change,
Colour just
but they're
going
just
out
heating
straw.
up.
Yeah. And then I had no idea.
Yeah.
So you submerge it in this lava.
Yeah.
For how long?
Depending on the size of it,
Right.
depending on what hardness you.
So it's very. Well, you can't really do it in batches, can you? Well, batches if it's the same
Yeah,
part.
depending on how big the component is.
You're right. Okay, it's a similar size.
Yes,
Component
yeah,
for
yeah.
the mass of actual.
And obviously,
steel.
the bigger the item,
How big is your wheel?
200 mil
About
diameter.
200 mil is quite a solid lump.
How thick?
Like that.
100 mil.
Yeah, about a bit less
that's
than
what
100.
being there for 2 hours. At 840.
Wow.
Do you know you said they
I think
cooled
they-
it with gas?
Gas, I think. Yeah.
So it'll either be put into oil or into a water tank. So that'll be brought over. If it's too heavy, it's brought over on the crane and then dipped in.
I was not expecting this at all. Completely blown away.
Just
And what's so? Is this similar to like an engine oil? Like
That's suspension oil, they call it. I don't know the constituents.
But it's
like
an oil.
Yeah, yeah.
And that's what temperature is that?
That's
Just
ambient.
ambient.
Yeah, it's been off all weekend, so.
Oh, it's not bad at
If
all.
it's quenched in water, generally you tend to get the grey, but if it's in oil, you tend to get the black.
Yeah.
And then just different materials just come up differently.
So this is steel, isn't it?
No, that would be like EN36, so that would be a good quality mild steel, which has been quenched in oil. Because certain customers ask for like a chemi-blacking finish.
Yeah, I was going to say, so that would be
So
kind of
this
suitable as a finish.
anti-corrosion sort of
Yeah.
thing as well. But normally 9 times out of 10, most things we heat treat are ground as well. So you'll end up with, if this journal's ground and this head, you'll end up with the black on the parts that are not ground.
Is that a suitable, like a sort of chemical black finish?
Yeah,
it will eventually rust, but if you keep
It will do, yeah. But
That's interesting, because then that'd be that. I've got one of my original wheels. Looks
Yeah.
like that. The face
yes, it's black.
is
but
black, and then it's
but
got the
shiny
actual
on the
shiny on the
actual
lip. So
working.
it's probably that
Yes.
case art, that sort of from being heat treated. Leave that face black,
Hmm.
and then ground and polish the edge. Yeah.
This is another we'll use for stress relieving and also for tempering.
So you temper it after. Yeah.
Yeah.
Okay.
So obviously
That's kind of a bit more what I was expecting.
Yeah.
Yeah. So you put it in there just to bring it up to not quite as hot.
yeah, just to sort of relax it a little bit so it's not.
But am I right in thinking that with the tempering afterwards, so you'll heat it up in there, quench it, that gets
Yeah.
maximum hardness.
Yeah.
Then you'd let it cool, well that would cool it.
Yeah.
It would go into this oven to be tempered, so it'd bring it back up to not 800 again though.
No,
it'd be-
no.
Well, What do you want? 50 rock well, is it roughly?
Oh, into the 50s would be nice.
Yeah, so it'd be about 200.
200,
yeah.
and it would just sit there and
How
then
many
cool
hours
slowly.
normally?
Something that size, I would say it'd be about 6 hours. Something like that.
Really?
Yeah.
That'll have to be on for 6 hours.
Yeah.
But you don't realise it takes probably an hour to 2 hours to get up to temperature. So it could probably be on for 8 to 10 hours, depending on how long it takes to come up.
Wow. So then you can put a few jobs in there. Because
Yes,
you're only,
yeah.
When these wheels were made, in the original documents that I've got, they talked about the top wheel being case hardened. So I did look at that route, but I kind of prefer I guess EN24 wasn't available then.
Probably the initial cost as well.
Of buying
Even
them.
today, the N24 is probably 3 or 4 times more expensive.
So you could use a cheaper stock steel,
Mild steel. is
Just
obviously
normal
a lot
mild
cheaper,
steel, and
probably
then-
more readily available as well.
and then case harden it. So
Yeah.
you'd get the out of that working
Yeah.
surface.
You can get slightly harder, can't you, in case hardening?
They're going to have, rather crudely, they're soft as anything now. They'd be like 0 Rockwell, roughly
Oh.
0 and 10.
Wow.
But they'll be impregnated with the cyanide. And they'll have a depth of like 0.75 mil deep all the way round, and then go up to like 60 Rockwell. Once they've been quenched, one thing I didn't mention, we clean it, get all the oil and the slag off or whatever
Yeah,
would be on
because
there.
those parts in there look really lovely.
Yeah,
Look
and then
like
I may pressure wash it sometimes, but then
Sure.
then they go in for temper. You can see it's mould, so all I do is, rather crudely, your wheel would be on a rod.
Yeah, dunk
I
it
just
in.
immerse it into the neutral salt. And for like these are dowels, I put them in a basket, which are a lot easier because I can't wire these. Normally I would wire everything.
Yeah, but they haven't got holes in, or you can't,
yeah.
they're tiny.
So I just immerse. See that pour over the component, which is basically what it's doing. So like your wheel going in,
Will end up,
it just shows the molten salt pouring over the top of the basket. It's quite good. And going through the bottom of the basket.
That's beautiful. So cool. Cooked my camera. So when you open the fridge door.
Yes.
Yours would be at 840, but because we're casing, I do that at 900. So
Okay.
it'll
so
take
we go
about
up to-
half
yeah.
hour to get back to 900 now.
That's so cool. Meeting the guys at Wilson Tools and speaking to them sort of opened my eyes to the whole heat treating process and what I should do. So at the moment, that top wheel and the route I've been taking is making the wheel from EN24, which is a fairly decent steel, that is hardenable. Then it goes through the heat treating process and it through hardens it to, I should be able to get into the 50s, 50, 55, somewhere thereabouts, which will be plenty hard enough for what we need. And that would be all the way through, the entire wheel. Today is the day that Wilson Tools are actually performing the heat treatment process on that top wheel. I've asked them again, if possible, they can film it or take some pictures or anything they can do, because I'd love to see it actually getting, I don't know, I would actually like to see it, how much that's cost and how precious that thing is to dunk it in that 900 degrees, 850 degrees lava is a little bit worrying. Then if they send those pictures before this video goes out and I can get them to Dan in time, here they are now.
Okay.
Yep.
62. Okay.
'56 Rockwell, spot on.
There you go. Isn't that awesome footage? How cool is that? It's terrifying to think that my wheel has been submerged and came out that red hot, literally 850 degrees. This is the part where I need your help. So any engineers and mechanics and machinists out there that are familiar with grinding, this heat treating process will slightly distort and overlyze and move this wheel. And I need to make sure the outside surface is perfectly round. Literally needs to be perfect. We can't have any run out because it will start it would change the pressure on the machine. So it's really critical that it is absolutely perfectly round. To achieve that, after it's been hardened, the best way is to grind it. But this top wheel runs on a bearing, like a sort of skateboard wheel bearing that pushes on to that axle. So would you grind the outer diameter of the wheel, the final working finish of the wheel, to the center of the wheel? So just grab the actual wheel as it is in the chuck, put like a, make some sort of jig or axle or something like that. Would you grind the outer surface to be sort of concentric to the inner surface, the actual bearing face? Or would you install the bearings and then use the actual inner shaft diameter of the bearing with a dog to drive the wheel to grind the exterior? I hope that makes sense. I really don't know if it does or not. Would you grind it with the bearings in situ? That is kind of what I'm asking. In my head, it makes sense to grind it without the bearings in, because if there's any discrepancy in the bearing, you're just going to be sort of duplicating that and machining that and grinding that into the actual final wheel. So I guess over to you. Please leave a comment, start the debate. I'm all ears. What do you reckon? We could try both ways maybe. I'll get another one made and we'll try both, but I'm not sure what's the best way to do it. So over to you guys. Let me know. I welcome any comments. Thank you. I'll tell you what, next week is going to be a fantastic video because we are going back up to Bicester Heritage, to the Bicester Scramble. And this time, Dan is coming with us, so it's going to be a beautifully shot video. I cannot wait. We're going to meet the guys at Heritage Skills Academy. We're going to hopefully meet a lot more other amazing, interesting people. That's going to be next week's video. So please tune in. I hope you enjoy it. Thank you so much, and I'll see you next time. All the best. There are some options there. Oh, my card's run out. Yeah, my card's run out. Hang on.